there's a lot of math, big math going on behind the scenes. Okay, here we go. I've wiped out our program and we're going to start working with PID. The first thing you need to know is you do not just take a PID and drag it in here into your function block, into your main or something like that. If we go in here and add a new block, there was this one up here, organization block. I said, you're almost never ever going to use these things. You usually don't want something just cutting into the middle of your program. Well, guess what? The PID is the one thing that you do want cutting into the middle of your program. It has to, okay? So what we want for setting up a PID, we want a cyclic interrupt. And you see here it says allows you to start programs at periodic intervals independently of cyclic program execution, okay? So we'll just leave this on 100 milliseconds. That may need to change depending on your process, but that's not an answer that I can just say, oh, you put 55 in there and it's going to work all the time. Sorry, it doesn't work like that. But as a good starting place, 100 milliseconds is excellent. So we're going to just hit OK on that. And now we've got our cyclic interrupt block. And actually, you know, I really should have changed the name on that to something that sounds a little bit prettier, but you know I didn't, so there it is. It's called cyclic interrupt. And when we get into that, you know, you see we've got a ladder. This is where we're going to drop our PID, okay? So over here on our instructions palette, that's not a basic instruction. We're going to come down here to technology, PID control, compact PID. And you see we've got 3 different types of PIDs that we can put into our program. And I'm going to just drop these things all in, even though we're going to delete them right back out. But just so you can see these things, and you would never set them all up on the same rung like this, obviously. But here we go. Let's close that down a little bit. Okay, we've got this first one. This is the compact PID. This one is the one that I'm going to show you how to use. This one is like your everyman PID. It's quick, it's easy, it takes a lot less setup, and this can be adapted to do lots of things. 90% of the time, this will get the job done no matter what the process is. Here you've got this 3-step, okay? And it says this is integrated for tuning valves. So if you're doing like a fluid process, chemical, water, something like that, and you've got proportional control valves that are being used to, you know, set a particular flow or volume in gallons or liters per minute, then this PID is optimized for that type of application. Okay? Now you've got this one over here, and you know, this is PID Temp. I'll give you a hint. This one's optimized for temperature, okay? So heating and cooling applications, this is the one to use. Once I show you how to set up the first one, you will be able to figure out how to set up the others if you need to. But I will tell you right now, none of this stuff is particularly easy. So let's delete those. And I missed my project tree, so I'm going to pull that back out. And here we're left with our PID compact. That's the one that we want to use, okay? So in order to run this thing, we need to set a few things. One, we need to set an input, all right? So I'll create something called input 1 here. Right click, define tag. That's going to be a global input, and that's an int coming in. I could make that a real or something like that probably. But yeah, I'm just going to leave that as an int and define it. Okay, so I've got an input coming in, and then I need an output going out. So I'm going to come over here and let's go ahead and give ourselves an output 1. We like it. Define the tag. That's going to be a global output, int, define. Okay, we've got it. The other thing that we need to set here is we need to put in a set point. So we'll go right here and I'll just call that set point 1. Yeah, set point 1. Right click, define tag. We're going to make that global memory for certain. And we'd like to make that an int, define. Okay, so we've got that part of it set up, but it's not that easy. Notice we've got this little toolbox icon here. Let's click that, and guess what? We've got all kinds of more setup that we can do in here. Fortunately, we don't have to do it all, okay? So let's set some of the stuff that we do need to set, okay? So we've got our input and our output configured here. We've got the right actual places that we're setting those up, our inputs coming in and our outputs going out. We can use inverted control logic if this is determining the relationship of our input and our output. If we need to raise our output value in order to lower our input value, then we want to click this and invert control logic. If that's not the case and we're actually going to raise our output value to raise our input value, then we're good the way that we are. And coming down here, we want to make sure that our input and our output are set on the actual channels that we've got them coming in. And once we've got that, we should be good. So we can go ahead and close out of there. And let's see if this will let us load this onto the PLC. So we're trying it, checking, and the modules are stopped for downloading to a device. We're going to say go ahead and stop all. That's fine. And finish. We're imagining we've got this thing on a real actual PLC that's got a real processor and a real process rather. We're going to double click on this commissioning, and here we go. We've got this nice little, let me kind of close this down so we can see more of it. Now we've got this nice little chart, this graph set up here, and we've got our values right down here. So we can monitor this thing while it's running. We've got our set point, we've got our scaled input, what's coming in, we've got our output, what's going out, and we can actually see these values once it starts tuning itself. And at that point, we click on Start, and boom, magic starts to happen. Now, our input coming in is 0. Our output going out is 0. Our set point is set at 0. So, this thing isn't really going to be able to do anything. But in a real-world application, getting to this point, that's what's actually going to get this thing tuned, pre-tuned, tuned, fine-tuned, and then you're going to have something that controls process.